Hello class, it's exercise 10.3 and we are going to continue the same exercise which we were discussing in the last session as well. So in the last class we have attempted till question number 6, alright, about the permutation. We know very well that how to find permutation. The vector formula of permutation is NPR, which we had discussed in the last class, where N is the total number and R is what you are selecting, right? Now on your screen you can see that it's question number 7, which says that a 4-digit number is formed using 4 of the 8 digits 1, 2, 3, 4, 5, 6, 7 and 8. No digit can be used more than once. Find how many different 4-digit numbers can be formed if there are no restrictions. So what we need to do, we need to first verify yourself. If there are no restrictions, means there is no condition the number should be even, greater than 5,000. There is no limit. So what you need to do, you need to define a 4-digit number and how many possible arrangements are there if there is no restriction. So you have a time of 2 minutes to attempt this one, and then I will tell you the answer. So start. Alright. So for the first part, since we have how many digits? We have 8 digits, right? We have 8 digits, and among those 8 digits we need to select 4 of them. So it will be 8p4, and the value for 8p4 is equals to 1680. So if there is no restriction, there are 1680 possible arrangement. Alright class, I hope that it is clear to you. For the next part, it says the number is odd. Now there is a condition that it must be an odd number, right? So similar to even numbers, when we say that for even number the last digit should be 2, 4, 6, 8. So for the odd number, what should be the last digit, and how can you find the number of different arrangements using 4 digits from the 1, 2, 3, 4, 5, 6, 7, and we are forming a 4-digit number. So for the second part, we have a time of 3 minutes because there are different cases in this question. So start. Alright. So we are looking for 4-digit number. It will be 1, 2, 3, 4 plus 1, 2, 3, 4 plus 1, 2, 3, 4 plus 1, 2, 3, 4. We have 4 odd numbers here. For first one, I'm saying that it's 1, 3, 5 and 7. So we have finalized the places of last digit, which is odd number, so it's 1, 3, 5, 7. For the rest of the 3 numbers, there is no limitation, right? So we can say that among those 7 numbers, we have picked 1. So the leftover is 6p3, 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 6p3. Because the condition is only one that we have an odd number. So what I had 6p3 4 times, so I need to multiply it by 4. And your answer is, it's not 6, it's 7 for all these cases because we have total 8 numbers, right? We have total 8 numbers, so now it will be 7p3, 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 7p3. So your final answer, it will be 7p3 times 4. So 7p3, that is equals to 210. 210 times 4, it will give you the answer 840. That is your final answer for second part. Alright, so we had in 2 parts. For part 3, the number is greater than 6,000. So we are looking for a 4-digit number, right? 1, 2, 3, 4. If it is greater than 6,000, so what should be the possible outcome? First, you need to think about it by yourself. You have a time of 2 minutes, so start. Alright, so if you have a number that is greater than 6,000, that means it can be either 6, it can be either 7, it can be either 8, alright? So for the first place, you have option, it's 3p1, because there are 3 numbers and you can select any one of them. Either it can be 6, either it can be 7, either it can be 8. What about the rest of the numbers? The rest of the numbers, they are same. It's 7p3 because the leftover numbers are 7, and you can pick any numbers from those 7 numbers, alright? So the final answer, it will be 7p3, which is 210 times 3p1. Alright, the final answer you are getting is 630. That is the part C answer. And for the last part, it says the number is odd and greater than 6,000. Alright, so now you have two conditions. It must be odd and it must be greater than 6,000. So for this type of question, you need to make cases so that it won't be any confusion and you might get your answer very easily. So first give it a try. You have a time of 3 minutes and then I'll tell you the right answer. So start. Alright, so it says number is odd and greater than 6,000. So first let me decide. It's 1, 2, 3, 4 plus 1, 2, 3, 4 plus 1, 2, 3, 4 plus 1, 2, 3, 4. I finalize about the odd number cases which I had done in the part B as well. So it's 1, 3, 5, 7, right? We have picked one number. Now the second condition says it must be greater than 6,000, right? So for 6,000, for the first place, either we have 6, 7 and 8. So we have 3 P1, we have 3 P1, we have 3 P1, but for the last cases 7 is already being used, so now it's 2 P1. Alright, and for the rest of the numbers, since we have picked two numbers out of 8, that means the leftover numbers are 6, so it's 6 P2, 6 P2, 6 P2 and 6P2. Alright, now the final answer it will be 3P1 times 6P2 plus 3P1 times 6P2 plus 3P1 times 6P2, and for the last one 2P1 times 6P2. Alright, so when you solve all of this, you will get the final answer. It's 330, and that is your part B answer. Alright, so we are adopting the same strategy for each and individual question. When there are two conditions, we need to make cases because that will be quite easy and there is no confusion. Alright, that is the completion of your question number 7. After question number 7, we need to move another question. It's question number 8. Alright, it says number of form between the digits 3, 5, 6, 8 and 9. No digit can be used more than once. Or find how many different arrangements 3-digit numbers can be formed. Alright, so we need to find that out of how many digits we have. It's 1, 2, 3, 4, 5. Total we have 5 digits. And we need to find out how many 3-digit numbers can be formed. So that will be very simple. It will be 5 permutation 3. Alright, because there are 5 numbers and we need to pick 3 of them. So it's 5 being 3 gives you the value of 60, and that is your first part answer. Alright, for part B it says number using 3 or more digits can be formed. We have done the number for 3 digits, right? So what do you think if it says 3 or more digits? That means now it talks about 4 digits or 5 digits, right? So similarly, we have find the numbers for 3 digits. You can easily find the number for 5 digits as well. So you have a time of 2 minutes to think about it and find out the correct answer, and then I will tell you the correct answer. So start. Alright class, so if we are going to talk about that, it is using 3 or more. Alright, when there are 3 digits, so we say that it's 5 permutation 3, right? If there are 4 digits, we are going to say it's 5 permutation 4, and for 5 digits it will be 5 permutation 5. Alright, and we need to add them. So 5 permutation 3, that is basically equal to 60. 5 permutation 4, it's 120, and 5 permutation 5 is 120 as well. 120 plus 120, it's 240, and 240 plus 60, it's 300. So that is your answer. Alright, if you are using 5 digits, that is 3, 5, 6, 8 and 9, and you are going to make 3-digit number, 4-digit number and 5-digit number, so there are total 300 possible outcomes using just 3, 5, 6, 8 and 9, and that is your final answer. Alright, so I hope all of you are getting it. Moving on to the next one, it's question number question number 9. It says find how many different even 4-digit numbers greater than 2000 can be formed using the digits 1, 2, 3, 4, 5, 6, 7, 8 if no digit may be used more than once. Now, firstly, I'm going to highlight the conditions here. Firstly, we are going to make a 4-digit number, and that number should be even and it must be greater than 2000. Now there are three conditions. The first one, it's a 4-digit number. The second one, it must be an even number, and for the third one, it must be greater than 2000. So first give it a try by yourself, and you have a time of 4 minutes to find out the correct answer, and then I will explain you the stuff. Alright class, so what I will do, I will make cases here. Since we are looking for 4-digit numbers, so it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Why I make 4 of them? Because we have 4 even numbers. It's 2, 4, 6, 8. So either it's 2 to make it an even number, 4, 6 and 8. Alright. So the even number cases has been finalized because these 4 numbers make the whole number an even number, right? We need to add all those cases, and now the second condition, that it must be greater than 2000. So if it is greater than 2000, then for the first place we have the following numbers. Either it can 2, 3, 4, 5, 6 and 7 and 8, right? Since we have picked number 2 here, that means the leftover part for the first digit is either 3, 4, 5, 6 and 7, 8, right? So how many numbers we have? We have 1, 2, 3, 4, 5, 6, right? So we have 6 options, and among those 6 options we need to pick one option. Alright, why we have 6 options? Listen again. We have 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, because 2 has already been occupied in this case, right? Now, total we have 8 numbers. Out of 8 numbers, we have picked 2 numbers. So what are the leftover options? If we had picked 2 numbers out of 8, that means now we have 6 numbers, right? And among those 6 numbers, we need to pick 2 of them. So that is my first case. If you talk about the second one, right? We had picked 4 here. That means 4 cannot be at the start of this answer. So we cannot pick 4, but we can pick 2, 3, 5, 6, 7, 8. That will be same. It will be 6P1, because either it can be 2, either it can be 3, either it can be 5, either it can be 6, 7 or 8. So there are 1, 2, 3, 4, 5, 6, right? And among those 6 numbers, we can pick any one. And for the leftovers, we have 6P2 here, right? For these 2 numbers. Similarly, for this one, again, it will be same. It's 6P1 and 6P2. And for the last one, it will be same, 6P1 and 6P2. So the final answer we are getting what? We are getting 6P1 times 6P2. And how many we are getting? We are getting 1, 2, 3, 4. So you need to multiply it by 4 as well. And the final answer will be, it is equals to 720, and that is your final answer. So I think that this breaking your question in different conditions will make the solution very easy, and we have a clear idea that what are the conditions for the even number. If it's greater than some specific condition, then how to meet that criteria. So we had discussed the same number of questions, same conceptual questions in the topic factorial as well, right? And we are going to practice some more questions when we are going to discuss about the combination topic. Alright, so I hope that you also got the idea of permutation and for the how to find the different arrangements, right? So this is the main concept of the topic permutation here, and you will experience same conceptual question in the past papers as well. So make sure to practice all those questions carefully, right? Because the best the concept you have, the more you can attempt the past paper questions without making any mistake. And for your homework question, you need to attempt question number 4, right? It's an easy question. It says that there are 8 competitors in a long jump competition. In how many different ways can the first, second, and the third prizes be awarded? Now this thing matters most because it defines the arrangement. It defines that there is a specific order. Okay? The order for the first, second, and third defines that this question belongs to the permutation. So you need to give it a try by yourself. Alright? And inshallah in the next class we are going to start with the topic combination. So what you need to do, you need to practice permutation very well, because most people find this topic a little bit confusing, or difficult topic, but I think that it is not that much difficult, right? So give it a try by yourself, and I hope that all of you will get the right answer. So see you next class with a new topic combination. Till then.